First of all, thank you very much for joining us this morning. Very briefly, let me inform you about our company. We have established our company in 2010. Our main headquarters is situated in Ataşehir, but we will be moving to Teknopark Istanbul soon. Most probably in the month of November, we will be in our new building. We do have a manufacturing facility and also R&D laboratory, and we develop some products with our expertise. We do have computer-supported engineering systems. One of them is R&D and engineering solutions, and the other one is the renewable energy solutions that we provide. On the renewable energy side, we are making use of the computer-based, computer-supported type of engineering processes. We are using CFD technique. As the engineering solution provider, we are providing some services and solutions for our customers. When we look at them in clusters, in the very first core phase, we are doing verification. We are giving verification services for the designs, and performance and weight optimization services is the second hand. And in the third side, we do have information and knowledge and risk analysis, and we give consultancy services. We also do have some foreign partners within this field. And from concept to prototype, we developed products. This is something that we develop on concepts. Generally, a metal piece is being redesigned with a composite approach, and we are also producing the prototype for this product. And serial production, robotic production systems, and quality equipment integration is the most experienced field that we are involved in. Enforcing your automation systems, integrating some robotic systems to increase quality. We do have some integrated systems that we provide high quality. We do have some solution partners. We are not providing all of the solutions by ourselves, but we are working with the right partners. I will be speaking about our partners later on. When we look at the composite materials, we provide a tailor-made design. Transforming a metal design into a composite sometimes is not being given advantage. And also transformation from metal to composite designs and sandwich design and optimization and robotic manufacturing designs, because there is a specific interrelated type of approach within this field. When you produce a material with a normal technology, you do have some limitations, and with robotic technologies, you also do have some limitations. And when you are doing the design, you need to do the design in accordance with the capability of the device. And vacuum infusion and RTM process simulations and training programs, and also further advanced trainings for the problem solution and material and processes. We do have some advanced composite material and manufacturing processes trainings. You see a mass structure on the very right side and steel flooring. It is going from 1 meter to 8 meter. We do have a filament line. It's a composite pipe structure. It's a cylindric profile, carbon epoxy material. This is a drone material. And for the thick composites, delamination simulations and analysis can be seen as some examples. Composites, other than composite services, we are providing some mechatronic systems and component designs. As you see on the right side, this is a triggering mechanism and suspension mechanism below side, and this is a mechatronic simulation. Other than those, we also do have some acoustic analysis for vibration. We do have different softwares that we use for analyzing and designing and optimization solutions. Of course, in specific for the composites, the process in order to develop a tailor-made product is changing from design to design. When you are designing with a metal piece, the criteria for the optimization and the damage criteria are changing. So, analyzing a very complex structure is asking for different methodologies, different approaches. In the first step, we need to have the performance criteria. You need to cope with the performance criteria in order to gain from weight, in order to decrease the weight. When you place a target, achieving that target is not being that much easy. In the carbon composite structures, gaining from weight is 80%, so it is possible to decrease the weight 80%. However, in the past, in the spacecraft and in the automotive sector, they could not achieve this 80%. They have achieved 50%, 40% of weight gain. So that is not being so much feasible. And sometimes you're not being able to get the product that you want at the right time and the right place. The basic factor for this is matching the composites and metals one-to-one. Many of you are working in the composite industry and you know it very well. Composite pieces do not like very sharp ends, and because they do have a fiber structure and they have got a layered structure, and they are having the residues of free signs, and they're having contraction and shrinkage problems. So for this reason, when you're going to make use of composite materials, you need to design and change the geometry in accordance with that product. And when you are carrying on this operation, within the industry, there are some conventional design processes that we come across, and over-design needs to be prevented. You need to take some preventive measures, and simulation analysis and ride tests needs to be done. 1.2, 1.25 is an achievable score, but 2.5 and 3 is being the scores for the security factors, and it is bringing you a heavier design. But when you're doing the design, there are some analyzing and simulation techniques which can be used integrated, and you're carrying on your operation in a shorter time, and you're having a better and highly qualified design. In the verification process, there are some different softwares that we make use of. Actually, neither of the software or the companies do have a comprehensive, inclusive solution provider. Each company is focusing on some certain systems, so they are providing solutions for some certain systems. For this reason, we are integrating different systems. SimCenter 3D is Siemens analyzing and simulation optimization platform. FEMAP software is modeling and analyzing platform. Hypersizer is making use of the analytic methods. What do I mean by analytics? we name it as numeric methodology. It is doing the finite element analysis and analytic methods within the industry or the academic studies is doing manual calculations with some formulas. In the aviation business industry, the process is going like that. The verification and certification processes are carrying on with these performances. All of the analysis, for example, when we consider the rowing analysis, composites and metals optimization and sizing and detailed analysis is being done with this. And FiberSim is being used for the illuminatic design. What do I mean by this? I have told you, metal pieces is a 2 meters piece and you're forming it and making use of this. But in composites, when you speak about 2 meters size, it means different layers. And related to their geometrical structure, they may have some different sizes. And according to your piece, for example, a fabric, maybe you see it in the fair, do have a width. It can be 30 centimeter or it can be 1.5 meter. But if your piece is bigger in size and if its width is not enough, then you need to redesign some spatial features. There's an overlap. There's an overlap strategy. When the fabric is going 0.2 millimeter, then you're overlapping another piece and it is increasing to 0.4 millimeter. And CAD-Wind software is for filament design and also filament coiling, and you're taking the codes and sending it to the machine, and for the analyzing, the right orientation and the right thickness is being transpassed to the system, and it is providing you an analyzing feature for this. And RTM works is for the systems which is using liquid resin. It can be a thermoset or a thermoplastic resin, but when we speak about a fluid type of resin, it is asking you some spatial features, and resin and fiber is going together, and with an heating process, you're activating the resin and making use of that. For the infusion or NTM processes, resin is being kept in a closed spot or is being covered with a vacuum pack, and when you just flow it at a certain place, the resin ports or the vacuum ports and infusion ports are necessary to be placed. Otherwise, you may have some problems. You may have some dry areas, dry zones, and you may have some for example, fluctuation and relation waving on the structure. So it is possible to create a design with this technology for the fluid resins. Siemens Sim-Centered 3D technology is a analyzing simulation and optimization opportunity for us. You see structural, dynamic and durability, composite, acoustics, motion flow and thermal type of different disciplines are being examined. Multiphysics is the interdisciplinary approach which is providing you. Thermomechanical analysis can be an example for this. With the thermal impact, you are checking the deformity of the structure, and if there is a fluid structure, what is the interaction between deformation? Since the flow geometry is changing, the quality of the flow is changing, so different disciplines can be analyzed by making use of this technology. There is a composite mixed material that we use in the automotive industry. Automotive industry is really working very hardly on the composite industry. In the development phase of the composites, and when we look at the manufacturing process, there is a huge difference. Automotive is making use of straps, and they're just welding it and making use of that. But when we look at the composites, their production, their manufacturing phase is not like that. First of all, you're preparing the fabric, and then you're cutting them and designing them, and after the curing process, really it's taking time. And for a 100% composite automobile, it is bringing a very big question mark. By 2025, when we consider the reduction in emission rates, there is a necessity of being light in size, in design. So when we make use of composites, it is bringing you that value which is being demanded. And of course, there are some metal pieces that are being used and some plastic pieces that are being used, but somehow composite and metal will be integrated. And metallic pieces, in the recent time, additive manufacture type of technology is being added, and it opened a new gate for the metal pieces. The process is not that much fast when we consider with the classical strap operation, but really it will be bringing you benefit in the near future about weight and also about technological features. Siemens is not only looking at this issue from the composite side, it is also looking at it in a more comprehensive way and looking at the mixed material designs. CAD design is starting from the geometrical design and then transforming it to the composite design. The present CAD designs is, in the past, was only working for geometrical design and also on the engineering sides, but now they are producing the interfaces, and they do have a composite specific fiber sim type of softwares. It's a cycle, actually. After doing the composite design, you need to do the analytics of this, and you need to have the engineering studies, and you need to optimize this design. So it's a cycle which needs to be revolved. And when we look at the analysis of the finite elements, we do have some solutions. The modeling of the composites and their coiling process for the finite element analysis is very crucial. According to the geometry of the fabric, the orientation is changing, as you all know it very well. Composites do have a strength according to the, of course, placement of the fabric. When we look at the, for example, linear type of, for example, tensile, when we compare it with the tensile strength, with the right orientation, it is possible to bring more strength and more resistance. And when we are calculating the orientation, the manufacturing orientation will be different. So during the manufacturing, you need to analyze it, and after that, during the using time, you need to analyze it. And when we look at the analyzing situation, you're looking at the structural analysis, and you're looking at the and also durability strength analysis, and also vibro analysis and RMS functions can also be taken as a result of these analyses. In the aviation business industry, there is a progressive diffraction analysis. Composites do have some criteria for the damage. After having the damage, the composites may be used. it is losing its rigidity, its maybe strength a little bit. If you're below the limits of security, in the extreme cases, for example, when you do the design, in accordance with that, you're having very heavy weights. If a plane is flying and if a damage occurs, you need to analyze how long it can continue to fly. Not according to the extreme conditions, but according to the operation you are making the design. But of course you need to know the product first of all which you produce, and you are doing the design in accordance with the, if there is a, for example, breakage in the fiber structure, it is not bringing you a big damage, but you need to know how long it can fly, but you need to analyze it beforehand and you need to apply some tests. And for the composites, you do have some analyses for fatigue range, and Siemens do have some studies about the fatigue range. For the composites, for the layered composites, with small strikes, with small beads, you can have some cracks inside it. And when the structure is operating, it is causing delamination. Another important topic about automotive industry is about noise and vibration. In the automotive business, on the metal structure, by making use of extra materials, it is possible to decrease the impact of noise. But composite structure do have some additives, and when you create some layers within the structure by adding an additional isolation, without adding any isolation material, it is possible to decrease the level of vibration. And it is bringing you a better advantage when you compare it with metal structures, and it is being more cost-effective. I have spoken about FEMAP. For the finite elements, it is a modern modeling interface, and it's a very cost-effective solution. Different complex or simple structures are being analyzed, and composite-specific type of results are being taken from this interface. Fan-ply module, for example, is observing the orientation changes during the operation, and for the sandwich structures, there is some stability calculations, and it is possible to carry on whether there is any damage or not. So it's a very cost-effective solution also. A hypersizer software has been developed by NASA in 1990s, and it has been spin-off from NASA, and they have developed this software later on. For the complex spacecrafts and rocket craft and also wind turbines, it is taking some pieces and panel by panel, it is resizing your structure, and more than 100 analysis, it is possible to carry on a damage report. It is, in the past, there were some industrial studies, and with the conventional methodologies, when you compare it with conventional methodologies, it is bringing you a better weight advantage. When the structures are becoming complex, the buckling is becoming very curious. Buckling is a type of damage which is occurring. If the material is capable of carrying the weight, and if a stress occurs below that, you're having a buckling stress, and you are having a type of downfall. And post-buckling is another structure which occurs in the aviation-based structures. Maybe you can see it in the planes. The outside layer is a very thin still, and it is causing some post-buckling effect. Post-buckling is a temporary solution. The thin layer is just, as you can see, having a temporary buckling, but the composite structures are becoming thinner, and the buckling is becoming very curious for the composite structures. And HyperScience is analytically calculating that. And for the finite element, it is possible to provide solution for the buckling analysis. In the linear approach, buckling is being observed globally, but it is not possible to analyze it locally. So you need to create another layer for this to observe the local behaviors, and you can get the local behaviors by the help of this software. And the sandwich to have the same difference. I mean, on the lateral side, the surface is sometimes having, for example, can have a damage, can have a wrinkling, and sandwich structure and honeycomb geometry is changing, and it is causing some outcomes, and HyperScience is calculating them. It is giving you the core thickness, and also it is bringing you the ideal size for the ideal conditions. And when you produce the pieces, when you manufacture the pieces, you need to integrate them. It is possible to connect them in two ways. One of them is sticking them by making use of sticker, and the other way of connecting them is making use of bolts and screws. And when you place a composite structure, it is not very easy to place holes. And HyperScience do have a spatial methodology, and the hole around and there's also stress around the hole can be, the tension around the hole can be calculated, and you can design in accordance with that tensile strength. Especially on the corners, you can have a load of stress, and you can have delamination. By calculating that, you can redesign your design. HyperScience Express is a simplified magician software. You see, this is a type of hood, bonnet, and it is a composite layered structure. On a very big fabric, you can place little pieces of fabrics, and you can have a lighter structure, and you can place them according to orientations you want. It is possible to achieve a light design. If this is a composite bicycle, for example, you can just weld the metal. Normally, in the conventional methods, they weld the metal pieces, but when you do it with the composite structures, by making use of smaller parts, smaller pieces, it is possible to create a more composite bicycle. We have so far spoken about the simulation optimization softwares, and also we do have a design issue, and we do have FiberSim, which has been developed by composite manufacturers, and they have collaborated with the academia, and they have analyzed the behaviors of the composites. The structure that you see here can be familiar for the automotive industry people. There are very complex geometrical structures. For example, when you're doing the press steel design, with a 20-30-year experience, it is possible to achieve this when you are formulating it. But for the composite structures, when you are placing the fabric on the mold, the red zones are facing with microbuckling or wrinkling problem. So it is being problematic when you place on the fabric naturally. It is causing a natural damage. So if you do not be careful when you place it layer by layer, in the first layer you are not having any problem. It is so much related with the orientation and the material. The second layer, when the buckling occurs, it is automatically coming you as a manufacturing failure. And when you produce the piece, when it is being tested, it is telling you there is a failure. So it is causing a problem. But with the fiber sim design, it is possible to have freeze simulation, and you're seeing the problems within your structure and you're making the changes in accordance with that simulation. Let me give you an example. You see here, there is a bead here, and when you place the fabric on that, it is causing a wrinkling, a buckling, or sometimes it is not passing here, and it is only going like a flat line. When you decrease that 26 degrees, here you are doing the right design and you're doing the right mold design, and you're having a damage loss. You're doing a damage-free, failure-free design. Let me give you another example. When you transform a metal structure into a composite structure, it is causing such kind of corners, sometimes not forming according to your design. When we transform it in a composite-friendly design, when you have curvy structures, it is taking form much better in the composite structures and bringing you a better ground. In composites, change of the orientation angle really causing a great difference. Carbon composites, maybe 2000 megapascal, and high strength megapascal and 6000 megapascal strength can be provided. However, when you shift it 5 degrees, for example, it is causing a 40% loss, 50% of strength loss. So right orientation needs to be designed, and also manufacturing in accordance with that design is very crucial here. FiberSim software, when we tell it from a graphic, providing you a process simulation. For example, for the dry fibers or any preparation, you can create the essential thickness. For the internal design, this is very crucial. When you change the thickness of the composite, if you do have another additional supportive internal structure or the device, you need to recalculate it. And it is possible to calculate the weight also. It is possible to calculate the costs, and it is possible to have the manufacturing design and draws. If there is an RTM structure or an infusion structure, it is possible to transform the data to the software. Why is this important? It is important because if we do have a fluid resign, and if we eject it to that system, one of the parameters is the permeability. And this permeability is so much changing according to the fabric that you use. If you do not transform it in the right orientation, the outcomes can be a failure. For this reason, right orientation and transformation of the right thicknesses is an advantage which is being provided by the software. And it is also possible to see the flat placement of this fabric. And there is ply cut. If you are using ply cut devices, you can make use of this and place them in accordance to this, and you're having less loss from the fabric, and you can cut it in the ideal form. And fiber placement, when you make use of the robots for fiber placement, it is providing an opportunity to design according with that robotic technology. And it is also transpassing the data to the analytics, and you're getting an analytics reports, and it is possible to create a composite manufacturing data. The main objective here is doing a comprehensive integrated comprehensive design of analytics, design and manufacturing. And it is bringing you the necessary specs and making you to design the ideal form. Actually, last but not least, we do not have any simple problems in engineering. Everything is very complex. Geometries are very complex, materials are very complex. It is not possible to carry on any operation alone. A lawyer can work alone. A doctor may work alone, but the engineers cannot work alone. There are different disciplines. And we do have electronic software technologies, and also we do have some spatial active sensors. So, mechanical engineer, electronics engineer, different disciplines, multidisciplinary approach is essential within this field. For this reason, you need to know what you're designing. And you are making use of simulation devices in the automotive industry. They have come to that level. We do have digital twin. You do have the twin of your vehicle. There is no material or there is no piece which is being placed without simulating. The durability of the vehicle is being updated from that simulated twin. Neither of a simulation solution can solve the problem alone. CAD-Wind is being used for the filament, and how you are going to place the filament on the mold, and you are seeing the CNC codes. And there are different techniques here. For the tank-like structures, the fiber that you make use of should not be slipped. So you're going from the long road, and you need to find a way. And the software is automatically calculating that and implementing that. If you need an extra thickness at a certain place, it is possible to arrange it with a code. And this data is being transpassed to the analytics. RTM works is being used for the vacuum infusion and manufacturing simulation. You see the filling of resin. You see the distribution on the body of the boat. You see a wing example. Maybe it's not that much clear, but there is a white zone here. This is the dry zone. In the RTM processes, in the carbon composite structures, which are very expensive, are closed structures. If you do anything wrong in the infusion phase, you'll see there are some dry areas. You need to make some additional application. During the infusion, since there is a vacuum bag on it, it is possible to see it, and somehow you're following and you're interfering the situation, or you're isolating that zone and you're adding an additional resin to that place. But RTM process is a closed process and you're not able to see the inside. About manufacturing and quality systems, as I have told you, we have developed our own Kompozit winding system. We are providing it to our customers. We do have a prototype and we do have a machine. We are working with a French company for the robotic fiber winding. Composite manufacturing process is a very crucial process. It's a very heavy and busy process. So it's taking a lot of time and it's taking a lot of labor work. And this automatic laying devices, taking the fiber from the bobbin and placing it and cutting it, and robotically it is providing you the manufacturing opportunity. It can be a dry fiber, or it can be a prepared material. If it is a prepared material, for the autoclave phase, if it is a dry fabric, you are just being placed it on RTM. In the aviation industry, they use it very frequently. The automotive business, as I have told you, more complex structure. The approach in the automotive industry is placing it on a flat place and forming it. So with a binder, with a chemical binder, it is possible to achieve this. About the quality equipment, about active thermography, we are providing some cost-effective systems. We developed filament winding machine. We do have innovation. We do have a carbon composite piece which we have used. Why have we done this? Because for the moving parts, we would like to consume less energy, and we would like to make the process faster. We have used a sandwich design, and it has brought us a better weight, a lighter weight in design. It is possible to do the winding in different ways. There's a pneumatic feeding and control also. There's a plastic control, and there's an engine system, and there is sign bat system. We have spoken about the robotic technology. As you can see here, it is taking the fabric from the board in the prepared materials. This sign is a very fluid material, and you're melting it, and you're also sticking it on the mold by the help of this technology. We do have active thermography system, which we are making use of a German technology. It can be a halogen lamp, it can be a flash lamp, and with the heat of these lamps, you are finding out whether there's a failure on the structure or not. On the back side, the supportive sides are having some damage, for example. You're seeing the cracks, you're seeing whether any loose part, any loose, for example, the rivets or fasteners. This is a mobile system with a vacuum legs. It is sticking on the structure. With the thermal cameras, it is checking the damage and failure. There is a metal piece remain here. It is not possible to see it with the naked eye, but with the active thermography, it is possible to see this. And you can also make use of them integrated to the manufacturing lines. With the thermal camera, you see the distribution of stress on the structure in the military applications, in the laboratory applications. It is possible to use this. Another technology is the P-scan technology. It is working with ultrasonic waves. You can see it in our booth if you would like to see it. We can show you a demo. Failures and damage can be detectable by automated ultrasonic inspection. If there's a problem about adhesive, or if there is a delamination problem, or if there is a gel coat disbond, or porosity, or if there's a change in thickness, it is possible to see that. Porosity type of other problems can also be observed. Design, verification, manufacturing, and quality are the solutions that we provide. Problem-specific, right solutions is our motto. So we want to respond to the technical demands with the right quality and cost-effective solutions. You can find us in Hall C3. You can have further detail and you can see the ultrasonic device.